Assalamualaikum and hi to my students. This video lecture is about the topic of power set. The definition of power set is given as follows. The power set of A, we denote it as PA, is the set of all possible subsets of A. When we say subset, just recall back. Subset. Let A is a subset of B. The previous definition of subset that we encountered in our previous lecture is that all elements of A must be inside B. For example, if I take A as 1 and B is 2, 3 to 1, it's very clear that A is a subset of B, as all elements of A, which is 1, is inside this B. Also notice that B is not a subset of A, because not all elements of B is inside A. For example, 3 is not inside A, and also 2 is not inside A. The concept of power set is that we need to know how many elements, possible subset that can be any inside a given set. PA power set. So let me give you tips. Suppose we have A. The solution is there, by the way, but still I want you to go through to the process. Let's say we have A is equal to 1, 2 as the element. How many possible subsets can be made to be inside of A? You can quickly check here that 1 is a subset of this set. It's practically very easy. You can verify very easy. But the case right now, the problem right now is how many possible subsets are there. So let's start with this property from the previous slide. If two properties, this one. The first one is that A must be a subset of A. It means that all set must be a subset of itself. It's called as an identity property. And the second one is that empty set must be a subset for any set. This is quite logical because empty set you have nothing, and nothing must be inside something. So use this as your guideline. For this question, A equals to 1, 2. We focus back on the question. The question will be find PA if A equals to 1, 2. Based on these two properties, empty set should be there. Based on the second property, this one. And itself. Itself means I take the whole A, 1, 2 to be inside. Now we should have 2 more, because based on the given formula of the number of possible distinct subset is 2 to the power of n. So let's retrace back the step. The cardinality of PA How many possible distinct subset is given as 2 to the power of n, such that n is the number of distinct element inside. Right now, the number of distinct element of A is 2. This one, 2. So 2 to the power of 2 will be 4. You should have 4 distinct possible subsets. Right now we already have 2, empty set and itself. For the next 2, you should use the concept of combination 1, 2. This is fairly intuitive for you to find it. What are the elements left that can be a possible subset? It is 1, and another more is a set which contains 2. We have 1, 2, 3, 4. That concludes this example. We will proceed for the next one. Okay, we make our set A a little bit larger right now. A equals to 1, 2, and 3. We have 3 distinct elements. So before you start finding PA, or the power set of A, it is advisable for you to know how many possible distinct subsets first, and given by this formula, the cardinality of A is 3, so the cardinality of power set of A is given by 2 to the power of 3. 2 to the power of 3 is 8. You should have 8 distinct possible subsets. We proceed with the next work that we need to do is to find those subsets. We start first with the empty set and also itself. We have 6 more subsets that we need to find. We start first with 1, 2. Of course, you have 3. The combination of 1, 2. The combination of 1, 3. And last but not least is the combination between 2 and 3. Again, like the concept of Cartesian product, you must ensure that you don't have a duplicate subset. If not, you will not have enough elements to be inside of this power set. We proceed with 2 more examples. Let's look at example 2. Determine the power set. Find power set of an empty set. This question is special, but if you remember closely, how many possible subsets of an empty set? So empty set, the cardinality of empty set is 0. You don't have any element inside empty set. Therefore, the cardinality of an empty set is 2 to the power of 0. And 2 to the power of 0 is 1. So the power set of an empty set should only have 1. The collection of the subset, which is itself. This example really exhibits the combined facts of the 2 properties, which is the first one is that any set is a subset of itself, and you combine it with the second one, which is the empty set is a subset for any set. Let's proceed with the last example. Which is example 3. This example, example 3, I typo it, but that's fine, I write it back. Find power set. Suppose that A is given like this. So the question is that, is A empty? Is A an empty set? A is not empty. It contains something which I might call it as an empty set symbol and a set of an empty set as a symbol. So definitely A is not empty. But how many elements of A is inside? The cardinality of A is 2, given that these two elements are different. So PA should have 2 to the power of 2, you should have 4 distinct possible subset. Now how to construct the solution? The cardinality, sorry. Okay, PA. I start first with the opening of the set. It always starts with an empty set. This empty set does not come from the top. It comes from the properties. Empty set should be there. The second is itself. So what is itself? I take everything here from the top. I change the color. From the top, go to the bottom. Take everything. Itself. Itself. Be careful with the curly bracket. Now we have 2 more, which is a combination between those 2 elements. I write this one, this is the first one. It's a set with this element goes down. And the last element, I write the curly bracket first. Then I take the whole thing here, goes down. Did I write the large one? 1, 2. Close with the big bracket. Okay, this is the big bracket. And if you do it right, you remember the properties, the tips that I gave you, you will do just fine. So to challenge you, why not you do this example? Find, suppose I let B to contains this element. I change my element with infinite, empty set. This one, maybe it will be a bit too large. This one, I close it back. The question is find P, B. Happy trying. This concludes the lecture.